length of the perpendicular from a point on a straight line, from a point outside a straight line to the straight line, the length of the perpendicular. How can I deal with that? I'm going to say that if you have a straight line, L, its equation ax plus by plus c, and a point, for example A, and the point A here of coordinates x1 and y1, and the equation of the straight line ax plus by plus c equals 0. How can I find the length of the perpendicular from A to the straight line? It's going to be L. L is the perpendicular from the point A to the straight line. L here is going to be absolute value A x1 plus B y1 plus C absolute over the square root of A power 2 plus B to the power of 2. So, and A, B, and C are from the equation, coefficient of x, coefficient of y, and the free term, and x1 and y1 are the coordinates of the point A. Let me have an example. Find the length of the perpendicular from the point A to the straight line L. Let me find x1, it will be 2, and x2 and y1, let me prepare our items. x1 will be 2 and y1 will be 1, and A will be 3 and B will be 4 and C will be negative 30. In this case, we are going to have L equal absolute value ex1 plus b y1 plus c over square root of a power 2 plus b to the power of 2. It's going to be ex1 3 times 2 plus b y1 4 times 1 plus 4 times 1 plus c plus negative 30 absolute value over square root of a power 2 plus b power 2. It's going to be 3 power 2 plus 4 power 2. And here we will have 3 times 2 6 absolute 6 plus 4 minus 30, all of this over 5. This is going to be 10 minus 30, it's negative 20 over 5 absolute, it will be 4 length units. So this is our result. The length between, or the distance between the point and the straight line is going to be 4 length units. If you have this equation or in a vector equation, in a vector type, and the point is 4 and 5. So here we have x1 equals 4 and x and y1 equals 5. What about a, b, and c? Your equation must be in the Cartesian form, so we must change it into the Cartesian form. In here, we have, let's remember together, how can we use the equation of a straight line or change it from vector into Cartesian. Here we have the points 1 and 2. This is your point, and your slope is negative 4 over 3. The equation is going to be y minus 2 over x minus 1 is going to be the slope, negative 4 over 3. Make your cross multiplication. It will be negative 4. X plus 4 equals 3. Y minus 6. Move to the other side. it will be negative 4x minus 3y. Negative 6 move to the other side with positive 6 plus 4, it will be positive 10 equals 0. To make it easier, you will make multiply negative 1, it will be 4x plus 3y minus 10 equals 0. So this is our equation. Means if we deal with this equation, it will be right? Yes, it will be right. And now A will be 4, and B will be 3, and C will be negative 10. Let's find their length. It will be absolute value AX1, and here absolute value AX1, it will be 4 times 4, B1 3 times 5 plus C minus 10 over square root for the A power 2 plus B power 2, which is 4 power 2 plus 3 power 2. It's going to be absolute value 16 plus 15, 31 minus 10, it's 21 over 5. So it's going to be, this will be 4.2 length units. Next question, it's the same. Next question, find the distance between 1 and the 5 and the straight line passing the points 5 and the negative 3 and 1 and 0. First of all, we must find the equation of the straight line which passes these 2 points. You will make y minus 0 over x minus 1, y minus 0 over x minus 1, y minus 0 over x minus 1 equal the slope. Let me find the slope. It's 0 plus 3 over 1 minus 5. It's y over x minus 1, y over x minus 1, y over x minus 1, it will be 3 over negative 4. And in this case, we will find that x minus 3 equal this will be 3 over negative 4. Another time, let me say that here we have it's 3 over negative 4, and multiply, it will be 3x minus 3, it's a 3x minus 3 equals negative 4y. Then 3x plus 4y minus 3 equals 0. This is our equation, and the point is, this is your equation, and the point is going to be 1 and 5. In this case, we are going to find the perpendicular length. L is going to be the absolute value over square root. And A is 3 and B is 4, and C is negative 3 and x1, 1 and x2, 5. So we have 3 plus 4 times 5, 20, minus 3 over root 3 power 2 plus 4 power 2. The result is going to be 4 length units. 4 length units. Here there is M. There is the point. Calculate the radius of a circle which center 3 and negative 1 and touch the straight line 4x plus 3y plus 6. This is our circle. This is the circle. and it touch the straight line, or the straight line touch the circle at 1 point, just like that, and this is M. You know that M is the center, and if it takes tangent, it's a straight line touching the circle, so this is the perpendicular. So if you want to get MA, the length of the perpendicular, he asked to find the radius, and in this case, MA is going to be our radius. So A will be 4, MB will be 3, and C will be 6, and X1 will be 3, and Y1 will be -1, and start to find L. It's going to be 3 length units. The length of the perpendicular drawn from the point 1 and C to the straight line 2x plus 3y plus 5 equals 0 is root 13. Find the value of C. Find the value of C. You know that here we have A equals 2 and B equals 3 and C equals 5 and the L exactly root 13 and X1 equals 1 and Y1 equals C. And in this case, we can say that apply the rule. Absolute of AX1, absolute of 2 times 1 plus BY1, 3. C plus 5, all of this over square root A power 2 plus B power 2, 2 power 2 plus 3 power 2, this is going to be root 13. And if you move this part to this part with multiplication, then we have 2 plus 3C plus 5 absolute equals 13. In this case, we can say that 3C plus 7, because it's inside the absolute, it will be 13, or 3C plus 7 equals -13. So we have two values for the C. Now 3C will be 13 minus 7, 6, then C will be 2. And here 3C will be -13 minus 7, it's -20. So C will be -20 over 3. So we have two values for the C. Prove that the two straight lines L1 and L2 are parallel, then find the distance between them. How can I prove that they are parallel if their slopes are equal? How can I get the slope from the first? M1 is going to be -2 over 1, which is -2. And M2 will be 2 over -1, which is -2. Since M1 equals M2, therefore the two lines are parallel. Then he's asking about getting the distance between the two straight lines. Means we didn't take the distance between two straight lines. We just have taken the distance between a point and a straight line. What about the distance between two straight lines? If you get a distance between any point lies on one of them and the other straight line, in this case you got the distance between two straight lines. That means we have a point 5 and 8 which belongs to the second straight line. and the equation of the first straight line, which is 2x plus y minus 3 equals 0. And you can say that here x1 equals 5 and y1 equals 8 and A equals 2 and B equals 1 and C equals -3. And then we can find the L. If we have all the given, then we can find L as 3√5 length units. You have a square ABCD, and the point A, you have a square ABCD, and you have the point A, 2 and -3, and the equation of the BC straight line, which is 4x plus 3y minus 9 equals 0. So he has to find the area of a square. If you find the length of AB, the perpendicular distance from A to the straight line BC, which is the length of AB, now we have the side of the square, and you can get the area of the square. So here A is going to be 4, and B is going to be 3, and C is going to be -9, and also x1 is going to be 2, and the x and y1 is going to be -3. In this case, you are going to find L using our rule, which is ax1 plus by1 plus c over the absolute value, and get over the square root of a power 2 plus b power 2, you are going to have its 4 length units. Second question we have, ABC is an equilateral triangle. ABC is an equilateral triangle. You have the point A coordinates, it's 2 and the -1. You have the point A, it's 2 and the -1. If you know that this is an equilateral triangle, so each angle is going to be 60. And the equation of BC is x plus y, enter the 2 inside, -2 equals 0. He also finds the elements of the side of the triangle. Let me drop a perpendicular here, for example AD, and it's going to bisect the vertex angle and bisect the base. And if you got AD as a perpendicular from the point A to the straight line, we can say that it's AX1. So it's 2 plus by1 minus 1 plus c minus 2 absolute over square root of a power 2 plus b power 2, which is 1 plus 1. So now we can get that AD equals 1 over root 2. This is going to be your AD. And so now we can say that sine 60 here 1 over root 2. Each angle is 60, right? So sine 60 equal AD over AC. AD over AC. We can solve this as AC, which is the side of our square, AC, which is the side of our triangle, equals opposite hypotenuse. AD over AC, opposite hypotenuse, then AC will be AD over sine 60. AD over sine 60. So we can get that AC equals root 6 over 3. Root 6 over 3. So this is our result. Your homework will be page 120. And thank you, goodbye, see you soon, miss you a lot.